For this section, let's talk about complex numbers. Now, a complex number is a real number, a combination of a real number and the imaginary number I, which is, as you probably think about it, is the square root of -1. We will have a real number represented like a plus, and it could have, I could have a coefficient in front of it like b. So it could have a real number multiplied times that, but that's what we call a complex number. And we're going to add and subtract them in this first part here. And I've got two of them, 3 plus 4i. And that's going to be added to 7 plus 5i. So when we have plus in the middle of something, we really don't have to do any distribution of a negative or anything. So really we can just kind of ignore those parentheses and we can add the 3 and the 7 and we come up with 10, of course. And then we can also combine the -4 and the +5, and that would be the same as 5 minus 4. So really what I've got is plus 1i, and I would just write 10 plus I. Now they want the answer to be written in that format, which is the real number first plus the imaginary number next. Now let's talk about the next part. The next type is where we have an imaginary number and we are going to subtract an imaginary number, or we're going to subtract a complex from another complex number. This time we do have to distribute the negative. So let's do this. Let's just go ahead and write the first one down. And let's take the second one and say -9 minus that -6i gives us a positive 6i. All right, now I can go ahead and just add them together. And I have 3 minus 9 gives me a -6. And then I'm going to take 6i plus 6i, and I have 12i. Okay, for part 2, let's look at what it means when we multiply complex numbers together. Now, you might remember that and this is something you need to memorize if you don't know it already, is that I times I is going to give us I squared, and I squared is really -1. So we can go ahead and resolve it and not have an imaginary number when we have I squared. First, I'm going to be foiling these. If you don't remember that, how to do that, we've got a polynomial times a polynomial, binomial times a bi, and what we're going to do is say, I'll just write it down this first time. We'll do first, outside, inside, and last terms is how we would multiply them together. First terms is the 5 times the 8, and that would give us 40. Outside is the 5 times the -6. Be sure you watch the signs. It's going to give us a -30i. Inside, -2i times 8, -16i. And last terms is going to be -2i times -6. Well, negative times negative gives us a positive 12, and that's going to be I squared. And as soon as we have an I squared, we recognize that it's a -1. So -1 times 12, I'm just going to go ahead and circle it and replace this with -12. So what do I have? I have 40 minus 12. That gives me 28. And then I can combine these two, which are the I terms. -30 minus 16 is going to be a -46i. Let's do the same thing for number 4. And of course it is really a binomial times a binomial. So you would FOIL. Let's do the first terms. 5 times 10 would give me 50. And then I'm going to do outside. I'm going to say 5 times the square root of -36. Okay? Well, the -36, square root of -36 is really going to be 6i. I can go ahead and replace that with 6i. I can also replace this square root of -121. I can take out the square root of -1, which is I, and then that would mean the square root of 121 is 11. So this is really 11i. Now, let's do the multiplication now. 5 times 6i gives me 30i. Inside terms would be 11i times 10. Excuse me, 11i times 10 is going to be 110i. And last terms, I'm going to say 11i times 6i. And of course, that would give me 66i squared. Once again, I have a positive 66i squared. That's multiplied. I squared turns into -1, so I have -66. 50 minus 66, -16. The two I terms, when I add them together, is 110 plus 30, or 140i. Now this last one is a binomial squared. which can be written out again, but you should be able to kind of do this in your head without it. I'm going to write it out one time, and after that we have to move kind of quickly with algebra in this class. So you'll go through the shortcut most of the time to do it. 3 times 3 gives me 9. Outside, 3 times 5i is going to be 15i. Inside, 5i times 3 is another 15i. And last terms, 5i times 5i, 25i squared. I can take that I squared term and say negative 1 is I squared, so this is really negative 25. 9 minus 25 gives me a negative 16. And add the two I terms together, I'll have 30i. Now, if I was just doing this without writing it out, I would square this term, multiply the two terms together, and double it. And that might be something that you want to brush up on as we go forward. Let's look at the third type of problem that we're going to work with complex numbers. And this is finding the principal square root of a negative number. Now, the principal square root is going to be the positive square root of it. So if we are changing the square root of negative 16 into finding the principal square root and taking the square root of negative 1 out, you remember how we do that. This is really, we have to think of it as the square root of negative 1 times 16. Square root of negative 1, well, that's I. Square root of 16, that's going to be 4. So this is really 4i. Let's look at this one. I've got the square root of negative 4. Well, you can think about that as the square root of 4 is 2. Square root of negative 1 is I, so 2i. And then I'm going to subtract the square root of negative 36. Well, I would take out the square root of negative 1. Square root of 36 is 6. What have I got? 2i minus 6i. I have a negative 4i. And for this last problem, I've got the square root of negative 25 that I need to resolve first. Then I'll be multiplying it times 3. So I'm going to write it in parentheses. That's going to be 5i plus 4 times whatever this resolves to, and this resolves into 6i. So let's multiply, distributing our multiplication. Really, this is 15i. And this is 24i. And I can now add those together, and I get 39i. Now, one thing that we want to talk about is when we have fractions, we don't really want to leave imaginary numbers in the denominator of a fraction. So we try to, we try to resolve that, and one of the ways we do it is by using complex conjugates. Now, in this example, you're going to have to remember that a conjugate is really a binomial, the same terms, two terms that are exactly the same with an opposite sign in between them. So if I had 5 minus x and 5 plus x, those would be conjugates of each other. And if you multiplied them together, something interesting would happen. Some of the terms would actually drop out. So what we want to find conjugates and multiply a conjugate times the denominator of a fraction. And so therefore we'd also have to multiply it times the numerator. And if we do that, we can resolve an I term, an imaginary number, because it'll become an I squared. That's the goal in this anyway. So let's look at this first one. It's 2 plus 3i over 2 minus 3i, and I'm looking for the conjugate of 2 minus 3i. Now, of course, it would be the same two terms, 2 and 3i, but the opposite sign. So it would be plus. And it actually matches the term that we have on top, which doesn't have to, but it did in this problem. Now I'm going to go ahead and put everything in parentheses because I'm going to be doing some foiling here with these two terms when I multiply. Now when I say, now what I've got to do is resolve this by foiling the top and foiling the bottom, and I'm going to write it out as one big fraction as I do that. In the numerator, I'm going to say 2 times 2 is 4, and then I'm going to do outside 2 times 3i is going to give me a 6i. Inside, 3i times 2 is going to give me another 6i. And last is going to be 3i times 3i, which is going to be a positive 9i squared. Now I'm going to go ahead and circle that one because I'm going to change it to a -9, okay? Let's do the denominator. 2 times 2 is again 4. And then I've got outside is 2 times 3i. Well, that's a positive 6i. And then negative 3i times 2 is the inside. That's a negative 6i. And then I multiply the last terms together. Negative times positive gives me a negative. 3i times 3i is 9i squared. Now, because this one's a negative, when I resolve the I squared to -1, it'll be -1 times -9. It's going to give me a positive 9. So what happens to these two I terms? They're on the bottom. Well, they cancel each other out. 6i minus 6i would be 0, wouldn't it? So it's like saying plus 0. All right, so let's come over here and finish this up. We're going to say 4 minus 9 gives me a -5. 6i plus 6i, well, now I have 12i. That's the top of my problem, numerator. And then I have 4 down here in the denominator, and 4 plus 9. Everything else went away. Well, 4 plus 9 is just simply a number, 13. Now, this is not the form that they wanted in. Look at the format you've got to use. It's a plus bi. So I need to separate the numbers out here. In other words, I need to write each of these over the denominator of 13. So I'm going to rewrite it. I'm going to say this is really -5 over 13. That would be my a term. And I'm going to say plus, what is the rest of it? Well, it's 12 over 13, and I can separate the I out from that fraction. 12 over 13 times I, right? And that would be my a plus bi terms. And keep in mind, that is the standard form that they're talking about. When they say write it in standard form, you should think a plus bi. All right, let's look at problem number 2. We need to come up with the complex conjugate of this denominator, and I'm going to be multiplying times it, and I know it's going to have the same two terms, so it'll be a 2 and an I, and opposite sign in the middle. So therefore I have to multiply the top of my fraction by the same thing. All right, so when I do this, let's see, I think I have room outside beside it. I think I left your room out here. I'm going to say 3 times 2 is 6, and outside 3 times I is 3i. Inside 4i times 2 is 8i. And then I'm going to say 4i times I, well, that's going to be 4i squared, which needs resolving, doesn't it? That's going to actually be -4. All right, down here in the denominator, I've got 2 times 2, which is 4. 2 times I would give me 2i. That would be outside terms. -I times 2 is going to be a -2i. That's exactly what I expected to happen. -I times I is -I squared. Well, -I squared is like a -1i squared. It's going to resolve into a +1. So let's combine these. I really say 6 minus 4, that gives me 2. And then I can combine these I terms, 3i plus 8i, that gives me 11i. Denominator, I really say 4 plus 1, it's going to be a 5. And these i's, of course, 2i minus 2i is just 0. So let's write it in a plus bi in standard form. Well, that would be the first number, the a term, is a 2/5. And the second one is going to be 11/5, and I would multiply that times I. Okay, next, number 3. Basically, these are all doing pretty much the same thing. Number 3, we need to resolve the I in the denominator of this problem. We're going to multiply times the complex conjugate. This is I plus 1, so we'll make the second one, the conjugate, I minus 1. I have to do the same thing to the numerator that I do to the denominator. Remember why we can do this is because now I'm really just multiplying it times the number 1, and that doesn't change anything. So let's do 12i times I. It's going to give me 12i squared. As soon as I see that, I can say -12, can't I? And then I'm going to say 12i times -1 is -12i. Denominator, I times I, is going to give me I squared, which, once again, that's a -1. And then outside is going to be a negative I. Inside is going to be a positive I. And last terms will be negative 1. That's everything. So let's resolve these. I've really got it pretty much here. I've got negative 12 minus 12i. And in the denominator, it's really going to be, this is a negative 1 minus 1, isn't it? Which is negative 2. Now, I can simplify this further. I can divide all of these by that negative 2, can't I? All three terms. I could separate this out and say negative 12 over 2, right? And I guess we could do it that way. That might be simpler for you to see it that way. Negative 12 over negative 2. And then I would say then plus negative 12i over negative 2. Now, I left the plus because I wanted to put the negatives all together, right? Plus and negative is the same thing. But I want you to see that I could divide all these by negative 2, or I could just separate them out. This first term is going to resolve into a positive 6. And the second one is going to resolve into a positive 6 times I. So it's a plus bi. I've got it in the standard format. Now let's cube something. When we cube it, of course, really what we're doing is we FOIL it and then we multiply it times a binomial again. So we write it like this. And then we're very careful multiplying all these ones and i's. So I'm going to do the first two. I'm going to stop right here and just do the first two together. I'm going to say 1 times 1, and then outside 1 times I, inside 1 times I, and last terms, I times I. I'll take a second and write that down as a negative 1. And then I'm going to say that has to all still be multiplied times 1 plus I, okay? I don't want to forget what I'm doing. Now, everything in parentheses, let's go ahead and combine it before we do this last multiplication, okay? So I've really got 1 minus 1. Well, 1 minus 1 is just 0, isn't it? And then I've got I plus I, so I've really got 2I. What do I do with it? Then I multiply it times this other binomial, 1 plus I. That's pretty easy. 2i times 1 and 2i times I. Once again, 2i squared, that's really negative 2. So what do I have? I have 2i minus 2. It's in the wrong format, though, isn't it? It needs to be as a plus bi. Well, a is a negative number. It's negative 2. And I is positive, the I term is positive, so it's plus 2i, negative 2 plus 2i.